All right, y'all, video 3. Let's go. Number 25, use the diagram below to determine which statement is true. So we're looking for which one is true, meaning that of these 5, 1 should be true, 4 should be false. So let's just go one by one. Answer choice A says that H is less than J. So far that's true. And J is less than I. Is 35 less than 85? Yes. But is 85 less than 60? No. Y'all can put stuff in order. So that one is a no. So I'm going to cross that one out. I'm going to keep going. HI is less than HJ. So H to I is less than H to J. 1 is across from 85. 1 is across from the 60. So is HI less than HJ? No. Let's keep going. Is JI less than HJ? So I'm going to redo this in the color coding. JI, this one, it's across from the 35, is less than HJ, which is across from the 60. That's true. Okay. And then that one across from the 60 is less than HI, which is across from the 85. That one is true. So I anticipate the other two being false if I did this correct. So let's just keep going just to check ourselves. Okay. Is HJ greater than HI? 1 is across from 60, 1 is across from 85. So is it possible for this one to be bigger? No, it is not. So that one's false. Okay, and then is the measure of angle I, which is 60, is that less than the measure of H, which is 35? No, 60 is not less than 35. So I know that that one's false. So I know that I did this problem right because I was looking for what was true. So again, that's probably one of the trickiest questions we've had on here so far, because not only are you looking for which statement is true, you're having to make comparisons for every single letter choice. All right, number 26 says in the diagram UV so UV and YW are midsegments, meaning that these are midpoints, okay? And it's parallel to this third side. And then UW is going to be parallel to this side, which means that these are congruent, these pieces. And that also means that when I'm looking at this problem, Juke, stop. Sorry, y'all, that's my dog. Those two are going to be the same. So 1, 2, 3. Okay, so find W to X. Find WX. Okay, so WX goes from here to here. That is going to be the same segment. That's half of this full one doubled. The full one is going to be 10, which is doubled the 5. That's the midsegment doubled, which means that W to X is going to be equal to 5. That's all we wanted to find, so we get to stop there. Okay. Use the diagram above to find WU. Okay, so no, it does bring me back. It wants me to go back up there and find what is WU. Well, WU is this piece right here. It is going to be half of this, which is 8, the third parallel side. Half of 8 is going to be 4. So we thought we were done with that problem, but we were not done with that problem, okay? All right, let's go to another mid-segment question. How do I know that these are mid-segments? Point F is a midpoint. It's got 2 markings on either side. Point E is a midpoint, and point G is a midpoint. We want to use the diagram to find from F to G. So from F to G is the mid-segment, and then here's my third parallel side. Make sure you remember this theorem for the exam. The mid-segment theorem says, triangle mid-segment theorem says that 2 times your mid-segment is equal to that third parallel side. That is going to be equal to that third parallel side. When I say that, I mean I'm talking about this one right here. So those are parallel. And if you double the middle, you get the third side. So I'm going to do 2 times 5x plus 7. If you double the small one, you get that bigger one, 12x plus 8. So I've got to use some distributive property here. Again, I'm going through the algebra fast. So if you're struggling with the algebra, go ask one of your math teachers for help. We would be happy to help you. And I'm going to get x equals 3. Now, this is one of those cases where I put a box around x, and so many of y'all are going to go try to find 3 as your answer choice, but it didn't ask you to find x. It asked you to go back and find FG. So I'm hoping you hear warning bells in your head when we go back and look at that and say, oh, I didn't actually find FG. I just found x. So I need to go back and plug that in. FG is going to be where you plug in x equals 3 here. So 5 times 3 plus 7. 15 plus 7 is going to be 22. FG, the segment FG, is going to be equal to 22. So now I found FG. I promise you this is tricky. Somebody is going to accidentally select 3. Not because you didn't do good math, but because you weren't reading the question. So make sure you're reading the question. That's why I always put a box around what I'm looking for, and I check it off to make sure I'm done. All right, this one says in the diagram, WY is the perpendicular bisector of this triangle, and of the segment AB, it says at least, which means that this piece is congruent to this piece, and it also means that's the bisector part. It also means that those are right angles. This yellow segment bisects this blue segment, and it wants to know what is the value of X. So again, I'm going to put a box around what I'm looking for. So I go to look, where is there an X? There's an X in 2 spots. There's an X, actually 3 spots. There's an X here, which I know that that blue piece should be equal to this blue piece, but I don't know what that other blue piece is, so I need to look elsewhere. There's an X here on leg AY. There's also an X here on leg YB. Well, I know that since Y is on the perpendicular bisector, those 2 segments are going to be congruent to each other, and so I can set those expressions equal to each other. This point is going to be the same distance away from A as it is from B. And so those are going to be equal to each other. And we get X equals 5. It said, what is the value of X? That's what I just found. So that's what I'm going to select. Okay. In the diagram on this next one, in the diagram, it says that these are perpendicular to each other. So that means that that's a right angle. And it says that OP is going to be the same length as PQ. That has that marked. Then it wants me to find from P to Q. So if it just told me that these are congruent, hold on, O to P is congruent to P to Q, then if that's 10, this piece is also going to be 10. Those are congruent segments, so P to Q is going to be equal to 10. It has a length of 10. Because point P is right there in the middle. In the diagram above, it says that case M ray is bisecting this angle. That's the angle bisector theorem. It's cutting it in half. And it wants me to find L to M. L to M. So who is in the same spot as L to M? That point M is on the, let me kind of darken it here. Point M is on the angle bisector, which means that it should be the same distance away, the shortest distance away from M to N as it is from M to L. So that would make M to L 8 as well. I wanted to find L to M. That's what I just found. Okay. This next one is interesting. I've got 2 triangles connected. I've got an equilateral triangle. All 3 of those are the same actually, connected to an isosceles triangle. Okay. And we want to solve for 2 things. It says the value of X and for the value of Y. So the first thing I notice is that there are no numbers on this picture, no numbers at all. But I know that in an equilateral triangle, all of the angles are going to be 60 degrees because all of the sides are the same and all of the angles are the same. 180 divided by 3 gives me 60. And then 60 and X make a linear pair. Those add up to 180. So X is going to be 120. Solving for X first actually allows me to solve for Y. Because I know that if this is 120, this is 120 degrees, this pink isosceles triangle on the right, that vertex angle is 120. The angles that sit on that base are going to be congruent, so angle Y is going to be the same thing as this. And so I can go 180 minus 120 is 60. And then I have to take that 60 and I have to divide that 60 by 2 because those angles are going to be congruent to each other. 60 divided by 2 gives me 30 degrees for each of these smaller angles, and so Y is going to be 30. Y is going to be 30. So if you color code, that will help you. This was an isosceles triangle. In that isosceles triangle, this leg was congruent to this leg. We had the vertex angle, so we did 180 minus 120, and then we split that evenly between those 2 angles. Very similar problem on this next one. We've got an isosceles triangle here. There's the legs. I'm going to highlight the base a different color just to help keep us organized. It says that this is 35, so this base angle is also going to have to be 35. Okay. Then I noticed the 90-degree angle happening right here. If this whole thing is 90, that must mean that this smaller angle is going to be 90 minus 35. 90 minus 35 gives me 55 degrees for this angle because those add up to be 90. To find angle Y, I'm going to do 180 minus what I've spent at the two other angles in that yellow triangle. So 180 minus 35, that gives me 110 degrees for y. Y is 110. So I found y. Let's check that off. Now to find x, those make a linear pair. So x is going to be 70. Those add up to 180. So x is going to be 70. Check off x. It didn't ask me to solve for z, so I'm not going to. Let's just keep going. Use the diagram above, dang it, to solve for w and for z. Okay, so it does want us to solve for those. Didn't see it, y'all. They tricked us. Okay, so w is on this outside piece, and then z is up here. And so, again, right when I thought we were done, this one adds up to 180, and so w is going to be equal to 180 minus 35. 180 minus 35 is going to be 155. 145, I'm sorry, y'all. I'm going quick. Got thrown off. 145. So I know that w is 145, so it narrows it down to these. I'm going to cross these out. And then z is going to be, let's do this in a different color. Z is going to be 180 minus the 70 I spent here minus the 55. So 180 minus 70 minus 55. So we know that that's going to be one of our other two choices. 180 minus 70 minus 55. That gives me 55 degrees. And so that is going to be answer choice, answer choice D. Z was 55. Okay. Two more on this one. You always ask yourself what kind of triangle is it. If it has marks, it has those marks for a reason. So this has two legs marked as congruent. So this is going to be an isosceles triangle. So I'm going to highlight the base in a different color. The two angles that sit on that base in an isosceles triangle are congruent. So if this is 35, immediately this is 35. So what is the value of y? Y equals 35 degrees. Check. Now it wants to know the value of x. It's isosceles, so what I'm going to do is I'm going to take 180 and subtract the two angles I've spent. That's going to give you 110 degrees. So what is the value of x? X equals 110 degrees. Okay. All right. Last but not least, what kind of triangle is it? This is equilateral, and because it's equilateral, I also know it's equiangular. All of those angles are the same. And so if I have a 180 degree budget to spend on a triangle and I want to find the value of x, I'm going to divide that by 3. Each of these angles in an equiangular triangle is always going to be 60. Find the value of x. I just did. So tune in for video 4.